Hi guys, welcome to Design Spark. Today we're going to bring you an update on Project Nautilus, and I've got the three gentlemen involved in this project and their relative companies. Do you want to make an introduction to Design Spark?
Yep, I'll go. I'm Mike Burrows. I'm the Innovation and Futures Advisor for Electro Components, and we are the lead for the project, looking at commercialisation and exploitation.
Hello, I'm Michael Corser, CTO with Invotech Limited. We develop robotic solutions for hard to automate environments, and we're working on bringing the Nautilus robot technology to maturation, ready for market.
Hi, I'm Matthew Fleming. I'm a Principal Integrity Engineer with Sonomatic, and we're on the inspection side of the project.
Great. So in terms of the project itself, it's been going on for over 3 years now, but could you just give our viewers who are not aware of it a recap on what Project Nautilus is and also the challenges that you needed to overcome with this project?
You want to take that one, Michael?
Sure, yeah, I can do that. So Nautilus, well, the Nautilus is a system for essentially online petroleum tank inspection. So worldwide, there are many thousands of tanks in downstream oil and gas plants, refineries, tank terminals, etc., in ports, which are slowly degrading through corrosion. And the only way to inspect those tanks, the tank floors, is internally. So presently, that is more or less done manually by emptying the tank, purging it of toxic gases, and then sending human operators in to carry out the inspections. So that's obviously costly and very time consuming. So what Nautilus does is essentially removes the requirement to empty those tanks, and it can go in online. So it's a robotic system, very compact and portable, and also safe for operating in explosive atmospheres. So it can be put into the tank remotely, and the inspection can be carried out by Sonomatic without requiring any access by people to the tank, which has obviously got enormous health and safety benefits, but also massive cost savings to the operator, and also increases the flexibility for the plant operator without having to shut down plant and that kind of thing. So essentially, it's a tracked robot fitted with inspection equipment, ultrasonic inspection equipment, that can sit on the floor of the tank, move around to most places within the tank itself, and carry out floor thickness measurements. And what it's looking for is corrosion, which may be coming in from underneath the tank, or it may be corroding from the top of the floor. And this solution can pick up very small and the corrosion pits and wall thinning, so we can actually watch the floor corroding and make an intervention before any problems occur, such as leakage of fluid out of the tank.
There's quite a lot of benefits there. You were talking about cost savings and obviously safety. You're not needing to put a man in the tank, but what other benefits would you say that to be had with this? Maybe in terms of the portability of the product as well.
I think one thing that is worth mentioning is as well as all the attributes that Michael's expressed in what we were doing, the project was about. One of the key features that we did while we were looking at the design of it, we went out to the whole industry, and I think we had something of about 100 contributors from around the world on exactly what they thought, the wish list, what they must have, should have, and like to have. So it has been built around that. And one of the other key benefits to this was the size and the portability, as Michael said. And when you look at the traditional ways of doing it, these robots are quite hefty pieces of kit, and there's a lot of risk involved in the deployment when you're trying to lift these things up to on the top of a main tank. So the benefits are, it's removed not just the risk for inspection, but remove the risk on deployment and the manhandling side of it. And with the portability and the size, it ultimately makes it easier to use, so then you'll get, more inspections. And the fact that it's tracked, as Michael said, what we can do then is redeploy it and then only inspect by exception. So rather than having to do a full tank, which you might take a week inspection, we can, once we've identified an area, you can redeploy it. So there is that added benefit, and it's almost like, you could argue when you're looking at when we lead on to where we're looking at some of the opportunities that we may have, is currently, if you use the analogy of currently to inspect a tank, predominantly you're looking at open heart surgery to get to the tank. And what we are now introducing is something that we can almost like non-intrusively inject into the tank, and it can do its business while the tank is operating. No major operations, no major. So it's got loads of benefit from increasing storage, the capacity, not taking things down. And as we've seen recently with the oil crisis, and currently when the price of oil, if we can increase the storage capacity, then obviously that leads to a better economics across the world.
Great. So lots of benefits there. Obviously, with the technology that you guys are using, you've had many different partners. So I know initially there were multiple partners in phase 1. Phase 2, predominantly the 3 partners. Do you just want to explain a little bit about what each of you guys are bringing to this phase 2?
Well, on our side, the original partners, we had London South Bank, we had the Welding Institute, TWI, then there was RS, or originally was Munition, then RS. Then we're looking at Sonomatics and Invitec. The TWI and London South Bank were basically looking at signal enhancement, for looking at the ultrasonics, which has ultimately been taken on board and run now by Sonomatics, and then the localization, or looking at some localization, which we've experimentally designed, and now we've taken that over, and Initec takes that. And obviously what we're doing now is looking at the commercialization. Now we've got a full working model and being able to actually take something, a product that is to market. That's roughly where we're at. I'm not sure if you have anything to add, guys.
I mean, so we've been testing the robot in the field. So we've been looking at the field data, processing that, improving that, so we can get the best quality out of our data, and improving our software as well, so we can look at stuff in real time. So as the inspection is carried out, we can identify areas of corrosion, and then we can also process this, so we can do some verification once the inspection has been completed. So phase 2 has allowed us to do more with the project than we could have completed in phase 1.
Okay, Matthew, just a quick question on that, because I think Mike mentioned earlier about areas of concern within the tank. So if you're plotting the location, you can save that data and retest that in an interval period, for example, and the robot knows exactly where it needs to go to. Is that right?
Well, you can use references to areas within the tank, so field joints, for example, which you can then use to locate certain areas of concern. So you can return to the same place at another time and identify whether any corrosion is increasing or if it's staying the same. So you can work out from that corrosion rate and then figure out a remaining life based on those results.
Cool. If I touch now just on testing and awareness, I know that you guys have been involved in some field trials in the UAE earlier this year. Can somebody just expand what those were and tell us a little bit about what the outcome of those were?
I can do a brief outline of that. So obviously the pandemic has restricted testing quite a lot, but we did manage to, as you say, do some testing in the UAE with a client. We inspected through water and diesel, And we were able to show with the inspection that a limited amount of cleaning was required on the tank that we were deployed into, and we were able to clean and inspect at the same time. So we managed to get some really good data, and it showed that the robot would work under those conditions really well.
Okay.
And from the back of that, we've kind of taken a lot of feedback on board from the guys in the field. And phase 2 has kind of allowed us to, rather than going back to the drawing board, iterate and modify the nautilUS platform. So it's been very helpful for us to get their practical feedback as to the tweaks and the upgrades that we can make.
Yeah, I think that's important, isn't it? It's always the test and the verification and the feedback loops that you can get from live data as well.
I mean, one of the key things here as well is I think Michael touched on it earlier when he said nautilUS is a system, and one of the other aspects which a lot of people forget, it's okay looking at the attributes of the robot itself and the inspection service, but it's also the deployment. So being able to deploy these effectively and efficiently, looking at the umbilical, which is one of the key areas, and how we keep that safe as well. So by doing these, in-field deployment, we've checked we also tested our logistics, the site safety that we've had to be involved in, not just the operation of the robot.
Yeah. That kind of leads nicely into this question about commercialization, because as you guys have been talking, you've developed some sensor technology, you've got the umbilical cord there, you've got the safety, you've got the actual build. What is it in terms of commercialization that we're looking at here? Is it a build service? Is it a service for inspection? Or is it a mixture of all of those elements?
It's a mixture of all of those elements. We've got, and I think Michael and Matthew will be able to comment on this, but what we've got a service where we can offer a service which is led by Sonomatics, and the service is using the nautilUS and other attributes. The nautilUS robot not only just does the thickness, it has a modular system that Michael could probably touch on, which we can add cameras, we interchange different sensors on the robot body itself. So we're offering a service that can be done through Sonomatics, and as I said, that's not just the robotic side. That's end to end, looking at all the safety aspects, etc., and also being able to supply a robot or a system. But as part of that supply of the system, there's all the training and the application side of it, which then will be headed up by Sonomatics.
Yeah, so really the market is looking for a turnkey solution. So we're looking to be able to offer as a partnership, we're being able to offer both the service and the equipment, but also consider the fact that it's a very dangerous environment that is being worked. Yeah. And so training is massively important as well. So through Sonomatic and through ourselves, we can offer the equipment that we know is designed to be safe, and Sonomatic can make sure that it's used safely through training customers on site as well.
Yeah. So
go on, Matthew.
Sorry, I was just going to say we've used our experience, because we've got like 30 years of experience of doing ultrasonic inspection on various sites. So we've been able to use that in this project to deploy the robot safely and interpret the results as well. So we can use our in-house training to get our technicians to the point where they can use this technology.
Right. And just if we think back, to when lockdown started and everybody's travel was kind of restricted, all of those storage farms for fuel basically became full. So in terms of the opportunity, what is the opportunity that we see with this particular solution?
Well, looking at the market size, it's growing as it's developing. I mean, the potential is over, it's over $1 billion sort of marketplace you're looking at. But as we said, when you're looking at the marketplace currently, it's based on what traditional technology, traditional ways of doing it, and everybody talks about disruptive and being disruptive. Well, this is if you like, not just the Nautilus, but the robotics industry at all is creating, a different level of disruptiveness within the business, because we can do these when they're online. So you're not taking them out. Currently, I think it's, and somebody can correct me if it's wrong, it is roughly about 10 years inspection time.
It's about that, yeah.
Yeah, about 10 years inspection time, and that's predominantly some risk factors and calculations, but in that risk factor will be the disruptiveness of the inspections that they have to cause. If we remove that, then and we speed up the inspection time, the deployment's no longer a risk. We're not putting men in harm's way, so it's possible that we can increase the inspections to be more frequent. Coupled with the fact that within oil and gas industry there is a drive to remove human beings from harm's way by, I think it's 2030. There's they want a lot of things to be manless and go into more this robotics. So whilst there's if you like, a traditional market, the market, the potential market is a big question mark. But we're using these disruptive technologies will clearly create new markets and new opportunities.
Yeah. That's an interesting point you make, by 2030 that they would like this to be manless. So although your project's been going for 3 years or just over 3 years, you're really now taking it to the testing stage earlier this year. What's been the level of interest from the industry itself? Is there any feedback that you guys can give us?
Well, from our part, we've been, there's roughly 600 tank farms worldwide, and quite a lot of them are the America, Singapore, Netherlands type regions where there's main areas, and we've contacted most of them, and we've got about 50 to 60 active discussions currently going taking place. So it's one of the, when you look at the interest, it's again, there's a lot of interest, but it's the safety factor, because when you're looking at what you're trying to do, you potentially putting a machine in a highly explosive or passing through an highly explosive environment. So it's the confidence of the operators, and this is what Michael and Matthew's teams are working on, is to remove that risk factor on theirs. I don't know if you can comment on that, Michael, with the umbilical and etc.
Yeah. So I mean, we haven't achieved it yet, but certainly on our roadmap is to achieve ATEX certification, which essentially allows us to operate in explosive atmospheres. I mean, it's a complex topic of discussion, but basically it means that the equipment is essentially intrinsically safe and therefore can't create an explosion if operated in the way that it is designed to.
Yeah.
So we expect to achieve that certification in this year, but to a level that's certainly a lot higher than any other competition out there, and we aim to be able to operate in sort of not just water and diesel tanks, but also sort of more light distillates, more closer to petrol, gasoline type of things, which obviously will open up a massive market that hasn't been open to robotic solutions until this point.
Yeah, we've seen an increase in interest over the past year, to be honest, with this sort of thing, and the ATEX rating would definitely help. I mean, we're currently doing several projects of cleaning and different types of inspection, but we're at the minute we're assessing whether other tanks would be suitable. So it's definitely busy.
I think one of the key points here is that we're trying not to just offer the robotic and the capabilities of the inspection systems. It's the system as a whole, as Matthew alluded to. The 30 years experience working in a highly hazardous, explosive environment, that is priceless. That experience to be able to feed back into the design, and also we can talk to the plant operators, the tank farm operators, and they know that we've got the experience to understand what their concerns are.
Absolutely. Yeah, it's such a volatile environment, or potentially can be. You don't want to have any real issues. And I guess from that safety level, it's more is it right? It's the insertion and the extraction of the robot is when it's at its most dangerous. If it's under the oil, it's not so much of an issue. Is that correct?
Essentially, yeah. So when it's under the oil, there's no oxygen present, so you can't get an explosion. It's the vapor zone at the top of the tank that's kind of the critical zone, where all the gases kind of float around at the top. And the opening point for these tanks is right at the top. You have a man access way, maybe a 500 or 600 millimeter access point at the top, which is where the robot is deployed. So it's during the deployment, when it's passing through the vapor zone, which is a mixture of air and gas, that we need to be extra vigilant. And it's a combination of having safety rated equipment and the experience and the training in the field that kind of make this solution more likely to be, much safer.
Fantastic. I don't have any more questions really. It's been a catch-up session to see where we are now with nautilUS, from the journey that you guys started back over 3 years ago to where we are now. It looks like we're in a really good position. Obviously, with the three of you guys being the spokespersons for your company and sharing your information today was great for us. And we still want to continue this story for nautilUS. So I hope to invite you guys back again soon to Design Spark, and we can carry on this conversation. So many thanks for joining us today, and wish you a good rest of the week.
Thank you very much.
Thank you.
Thank you very much.
No problem.
Speak to you soon.